Today we're going to talk about turbo modules. It's a very, very dense document and it's kind of hard to understand, and I'm just going to do my best to read it and understand what's going on. Feel free to jump in and ask any questions or correct me or answer my questions or some of the things that you don't understand. Make videos about it, and I'll be sure to follow up. So let's jump in right into it. So turbo modules. So this is React Native Community Proposals 11. So what is this? So turbo modules is a replacement for native modules for a way for JavaScript to invoke functions in Java or Objective-C. In essence, native iOS or Android code. So why do we have turbo modules? Why is this thing coming? So some of the problems that native modules face is they're specialized, they're specified in a package, and they're eagerly initialized, which means that the more native modules you have, the slower the app gets. So a native module can be initialized lazily using a lazy React package, but it does not work in open source repos. So this is one of the things that they're trying to address. There's no simple way to check to see if native modules are actually included. Native modules that JavaScript calls are actually included within the native app. So when JavaScript calls a native module, it doesn't actually know if this native module exists. So they're kind of separate in their own little islands. Native modules are always singleton in their life cycles, typically typed to the lifetime of a bridge. So native modules are very, very dependent on the bridge. This issue is compounded in brownfield apps where React Native Bridge might start or shut down multiple times, which means the life cycle of a native module is also going to be start and shut down multiple times. During the startup process, native modules typically specified within multiple pages. Then we iterate over this list multiple times before we finally give the bridge a list of native modules. So this is probably not very performance oriented. The actual methods and the constants of native module are computed during runtime using reflection. These individual calls are sent over a message queue. So this seems like it's something that's related to the bridge. So what they're doing is with the JavaScript interface, they're essentially making the communication between JavaScript and native synchronous. So what happens is instead of using a bridge to communicate between these two LANs, right now they're using the JavaScript. In the future, they're going to be using JavaScript interface, and then this middle part is going to be maintained by a C++. So the JavaScript is going to be holding a reference to these C++ host objects, and these C++ host objects is going to be invoking the Objective-C and the Java code on the native land. So that's what's going on. Defining native modules. So you typically use flow types to define native modules and their methods and signatures. So then that generates Java Objective-C with method stubs matching signatures, which can be extended for the actual implementation. So now they plan to generate C++ classes with the same shape, which can be used to call into Java and Objective-C implementations. Initial processing will be removed because C++, so there will be no initial processing. So C++ will know the shape of the native modules. Proxy, similar to the native module proxy. So the initialization happens when a root view is initialized. My understanding is when the root view is initialized, you will have access to all the native modules. And because they're independent of the bridge, this can also happen at any other times. Because they're lazily loaded, So I'm guessing at root view, only the ones that are needed are loaded. And then as you can just sort of add the native modules as they go at runtime. That's what it seemed like. Invoking methods on React Native, on native module when a JavaScript code requires. So this is how a native module is called. The getter on the proxy is called. It would then return a reference object generated in C++ with the shape of the native module. So JavaScript calls, when JavaScript calls it like this, it's gonna call the C++ code, and the C++ code has the same shape of the native module. Then C++ would then call the Java and Objective-C code. And then there are some open-ended questions, but I don't think I'm smart enough to figure this out. So I'll let you guys read this, and if you want me to go over it, let me know, and maybe I can do these open questions in a separate video. Thanks.